Bismillah, Assalamu alaikum wa rahmatullahi wa barakatuh. I'm Muhammad Saad al-Qahtani, and today I will be presenting about fused deposition modeling, also known as FDM. FDM is one of the most common and accessible 3D printing technologies used today. It is widely used in engineering, education, and product development because it is affordable, simple to operate, and very effective for rapid prototyping. In this presentation, I will explain how the process works, the materials used, its advantages and limitations, and its real-world applications. What is FDM? Fused deposition modeling is an additive manufacturing process. Additive manufacturing means building objects layer by layer instead of removing material like in traditional machining processes such as milling or turning. In FDM, a thermoplastic filament is used as the raw material. This filament is heated and it becomes semi-molten, and then it is extruded through a nozzle. The material is deposited layer by layer following a digital design until the full object is created. FDM was first developed and commercialized in the late 1980s. Since then, it has become one of the most widely used 3D printing technologies. How the process works. The process begins with designing a 3D model using CAD, a computer-assisted design or drawing software such as SolidWorks or AutoCAD or Fusion 360. Once the model is ready, it is imported into slicing software. The slicing software converts the model into hundreds of or thousands of thin horizontal layers and generates machine instructions called G-code. The filament is then fed from the spool into the extruder. Inside the extruder, the filament passes through a heated nozzle where it melts at a controlled temperature. The printer deposits the melted material in the X and Y directions to form a single layer. After one layer is completed, the build platform moves in the Z direction, usually downward, and the next layer is printed on top of the previous one. This process continues layer by layer until the final part is complete. Materials and components. An FDM printer consists of several main components. First, the filament spool, which supplies the raw material. Second, the extruder, which pushes the filament into the heated nozzle. Third, the heated nozzle, which melts and deposits the material. And finally, the build platform, where the object is printed. Common materials used in FDM include PLA, which is easy to print and environmentally friendly, ABS, which is stronger and more heat resistant, PETG, which provides a good balance between strength and flexibility, and nylon, which is very tough and suitable for mechanical parts. Advantages and limitations. FDM has several important advantages. First, it is relatively low cost compared to other 3D printing technologies like SLA or SLS. Second, it is easy to operate and maintain, which makes it popular in schools and universities. Third, it is excellent for rapid prototyping, allowing engineers to quickly test and modify designs. It also produces a minimal material waste because material is only added where needed. However, FDM also has limitations. The printed parts usually have visible layer lines, which affect surface finish. The mechanical strength in the Z direction is weaker because the bonding between layers is not as strong as within a single layer. Also, dimensional accuracy and surface smoothness are lower compared to more advanced technologies. Applications and conclusion. FDM is widely used in many industries. In engineering, it is used to create prototypes for testing, fit, function, and design. In the medical field, it is used to produce anatomical models for surgical planning. In the automotive industry, it is used for lightweight components and design testing. It is also used to produce functional mechanical parts such as brackets, housing, and gears. In conclusion, FDM is simple, affordable, and highly versatile 3D printing technology. Although it has some limitations in surface finish and strength, it remains one of the most practical and widely used additive manufacturing methods today. Personal applications. As a mechanical engineering student, FDM can be extremely useful for us. We can use it to print parts for design projects, mechanical assemblies, or experimental models. It allows us to quickly test our ideas before final manufacturing. Instead of waiting weeks for machining, we can produce a prototype within hours. Overall, FDM supports innovation, creativity, and faster product development. I have personally used FDM with a project that I presented to the Dammam University for a competition, which I got third place in, alhamdulillah. I designed a 3D model, which is a C clamp and a wheel, and I used these. That way I used 3D printing to make a small miniature prototype in order to present it to the judges. So it is very, very helpful. It didn't take any time. It only took maybe 1 hour or less than that. Since I learned SolidWorks at JIC, it was super easy for me. Thank you for listening.